What if the farmer of the future never gets tired, never needs a lunch break, and never complains about the weather? China is already building that future with laser-wielding robots, 2.0-story vertical farms, and autonomous machines that make traditional agriculture look like a history lesson. Here are 14 inventions that are rewriting how the world grows its food. Number 14. XAGR, 150 autonomous robot. Let's start with something that looks like it rolled off a sci-fi movie set, somehow ended up in a rice paddy. The XAGR 150 from Chinese agritech company XAG is a fully electric, completely autonomous farming robot. No driver, no supervision, just results. What makes it genuinely impressive is the modular design. The R150 comes with swappable tool attachments, so it can spray, seed, fertilize, and transport harvests depending on what the field needs that day. Think of it as a farming multi-tool that drives itself. Its four-wheel independent drive system and smart obstacle detection mean muddy terrain, sloped ground, and tight crop rows are just part of the routine, not a problem. Recent upgrades have also improved its precision and load capacity, making it viable for both small family farms and large-scale commercial operations. The driverless farm isn't a concept anymore. With machines like the R150 already in the field, it's a reality that's scaling fast. Number 13. AI-powered vertical farm. Would you believe a skyscraper could feed a city? In Shanghai, that's not a hypothetical, it's already happening. China has built the world's first AI-powered 2.0-story vertical farm, and the scale of it is genuinely hard to wrap your head around. The entire structure runs on hydroponics, LED grow lights, and a climate control system managed top to bottom by artificial intelligence. This AI doesn't clock out. It monitors every floor continuously, adjusting temperature, balancing nutrients, controlling humidity, and making harvest decisions in real time. The output is over 2 million heads of leafy greens per year, from a footprint a fraction of what traditional farmland would require. Water use is drastically lower. Energy consumption is optimized. And because everything happens indoors, weather is simply not a variable. It's the kind of farming model that makes sense in a world where arable land is shrinking and urban populations are growing. Shanghai just proved it works at scale. Number 12. Driverless farming tractor. Nobody expected the tractor, one of agriculture's most iconic machines, to lose its driver's seat. And yet here we are. China's latest autonomous tractor doesn't just automate one task. It handles the entire farming cycle, from plowing and planting all the way through to fertilizing and harvesting, completely on its own. The hardware is serious. Real-time sensors, precision GPS navigation, and an AI processing unit that lets it move through fields with accuracy that human operators would struggle to match. What elevates it beyond just a clever machine is the 5G connectivity. The tractor stays linked to a cloud-based control center, letting operators monitor performance and make adjustments remotely without ever stepping into the cab. In rural regions where the agricultural workforce is aging and shrinking, a machine like this isn't a luxury, it's a practical solution to a very real problem. Faster planting cycles, lower labor costs, and consistent precision across every pass. The driver's seat is empty, and farms are running better for it. Number 11. Smart greenhouse revolution. The greenhouse has always been a tool for controlling growing conditions. China's AI-powered smart greenhouses take that idea and push it further than most people would have imagined possible even 5 years ago. These facilities are layered with next-generation sensors, smart irrigation systems, and cloud-based data platforms that track everything: soil health, temperature, humidity, light exposure, and feed it all to an AI that makes real-time corrections. If a section of the greenhouse dips below optimal humidity, it adjusts before the crop feels the difference. If a particular growing cycle produced a better yield under slightly different light conditions, the system remembers and applies that learning to the next cycle. The results are measurable: higher yields, better crop quality, and significantly reduced resource waste compared to conventional greenhouse farming. In regions where land is scarce or weather is unpredictable, these smart greenhouses are delivering year-round production with a consistency that traditional farming simply can't match. Number 10. Automated rice transplanters. Rice planting is one of the most labor-intensive processes in agriculture, stooped over in flooded paddies, seedling by seedling, row by row. China's automated rice transplanters are making that image a thing of the past. And they're doing it at a scale that's already reshaping how major rice-growing regions operate. These machines move through flooded paddy fields, planting thousands of seedlings per hour, each one spaced and aligned with mechanical precision that no manual crew could sustain across a full working day. The more advanced models layer GPS and AI on top of the mechanical process, optimizing planting depth based on field conditions and tracking performance data in real time. Provinces like Hunan and Jiangsu have seen measurable improvements in planting speed, cost efficiency, and early crop health since adoption picked up. At a time when China is pushing hard on food security and agricultural sustainability, a machine that handles the most grueling part of rice farming faster and more accurately than human labor is not a small thing. Number 9. Laser weed, warrior, chemical. Herbicides have always been a necessary compromise in farming effective, but environmentally costly and increasingly restricted. China may have just found the alternative. Its first smart laser weeding robot is currently in testing, and the early results are turning heads across the agricultural world. The system works through a combination of high-end cameras, sensors, and machine learning that identifies individual weeds with pinpoint accuracy, then fires targeted laser blasts at the root to destroy them without disturbing the surrounding crop. No spray, no chemical runoff, no soil contamination. The robot operates fully autonomously, navigating field terrain day or night, adapting to different crop types as it goes. Early testing confirms it's not only effective but energy efficient in a way that makes it scalable. The broader implication here is significant. Herbicide use is one of agriculture's most persistent environmental problems. A robot that eliminates weeds with a laser beam, with no chemical trade-off, is the kind of breakthrough that doesn't come around often. If the testing continues to deliver, this could fundamentally change how the world manages weeds. Number 8. The AHPP bot. Harvesting tomatoes sounds straightforward until you consider what it actually takes: identifying ripeness accurately, gripping delicate fruit without bruising it, navigating dense greenhouse rows without damaging plants, and doing all of that for hours without losing precision. China's AHPP bot does every part of that better than most human pickers. The technology underneath it is what makes it genuinely different from other harvesting robots. It uses phenotyping and pose estimation to visually analyze each tomato plant in real time, understanding not just which fruit is ripe, but how it's positioned and how to approach it without causing damage. The robotic arm then executes each pick with a care that's engineered rather than instinctive. It navigates greenhouse rows autonomously, making continuous decisions without bumping into infrastructure or requiring operator input. For tomato growers dealing with tight harvest windows and increasingly scarce skilled labor, the AHPP bot doesn't just solve a logistical problem, it solves it reliably, at scale, every single time. Number 7. S400 and 50 Vineyard Robot. Vineyard work is precise, repetitive, and physically demanding. The rows are tight, the plants are delicate, and the tasks spraying, pruning, monitoring have to be executed with a level of care that traditional heavy machinery can't deliver. China's S450 intelligent vineyard robot was designed from the ground up to handle exactly this environment. Built specifically for table grape cultivation, the S450 is compact and agile enough to navigate dwarf grape systems, where a standard agricultural machine would cause damage just by entering the row. Its intelligent navigation and obstacle avoidance system allow it to operate without constant monitoring, covering roughly 1.2 acres, with precisely distributed spraying on a single run. Electric-powered, it runs quietly and produces no fumes, a meaningful advantage in the enclosed, managed environments where premium grapes are grown. For vineyard operators weighing the cost of labor against the consistency of automation, the S450 makes a compelling case. It's not just a machine doing a human's job. It's doing it with a level of accuracy and repeatability that humans simply can't sustain day after day. Number 6. Farming robot in Fujian. There's a version of agricultural robotics that looks great in a lab and falls apart the moment it meets real field conditions. Mud, heat, humidity, uneven terrain, and tight row clearances are not factors you can engineer around in a controlled environment. The farming robot making waves in Fujian province was built for all of it from day one, with a waterproof, ruggedized chassis designed to handle 9, 5 degree heat and saturated paddy conditions. This robot operates in the kind of environment that has historically required significant human labor to manage. It handles weeding, fertilizing, and crop monitoring, using onboard cameras and sensors to identify weeds, detect pest activity, and measure crop growth without any human involvement in the loop. Autonomous GPS navigation means once it's programmed and deployed, it manages itself across approximately 2.5 acres per day. The fact that it's already proving out in one of China's most challenging growing regions is the real story here. This isn't a prototype. It's working in the field right now, and the efficiency gains it's delivering for farmers in Fujian are exactly the kind of results that drive nationwide adoption. Number 5. DJI Agricultural Drones. DJI built its reputation making cameras fly. What fewer people realize is how aggressively the company has moved into agriculture, and how transformative that move has been for the way China's fields are managed. DJI's agricultural drones are purpose-built for serious farm work. A single drone can cover nearly 40 acres in a day, applying fertilizers and pesticides with a precision that reduces chemical use by up to 30% compared to conventional ground-based methods. AI-powered route planning and low-altitude obstacle detection keep the flights accurate and safe across rice paddies, wheat fields, orchards, and tea plantations alike. But the most interesting part of DJI's agricultural push isn't the hardware, it's the ecosystem being built around it. Across rural China, DJI is training young people to become certified drone pilots, giving a new generation both the tools and the technical credentials to modernize local farming and build businesses around it. The drone is the product. The certified operator network is the infrastructure. Together, they're scaling precision agriculture into regions that never had access to it before. Number 4. XAR-80 All-Terrain Farm Robot. If the R150 is the versatile workhorse, the XAR-80 is the specialist built for terrain where most machines give up. Muddy fields, narrow orchards, hilly landscapes, rows just 2.6 feet wide, these are the conditions the R80 was engineered for, and it handles them with a stability and precision that sets a new standard for what agricultural robots can operate in. 4 independently rotating wheels and a low center of gravity keep it upright and stable on ground that would strand conventional equipment. Real-time kinematic GPS positioning gives it inch-level accuracy across its spray, fertilize, and cargo operations, which directly translates to less chemical waste, better coverage, and cleaner environmental outcomes at the field level. Farmers can manage the entire system from a smartphone or tablet, scaling control across multiple plots simultaneously. In a country where agricultural land ranges from flat river deltas to steep mountain terracing, a machine that performs reliably across all of it isn't just impressive, it's necessary. Number 3. Strawberry Picker Bot Strawberries are one of the hardest crops to automate. The fruit bruises easily, ripeness varies plant by plant, and the picking motion requires a delicacy that most robotic systems struggle to replicate. China's strawberry picking robot manages all of it, and it does so with a level of precision that's made researchers and growers take notice. Using a camera-guided arm and a purpose-designed gripper, the robot scans each plant, identifies ripe berries based on visual quality standards, cuts the stem cleanly, and collects the fruit all within seconds per berry. The grip is calibrated specifically to avoid bruising, because a damaged strawberry loses shelf life and commercial value. It operates continuously in controlled greenhouse environments where timing and consistency are critical, never fatiguing, never losing focus. For an industry where strawberry picking is tedious, highly skilled, and increasingly hard to staff, this robot doesn't just offer an efficiency gain, it offers reliability at scale. Every berry assessed to the same standard, every shift, every day. Number 2. Mountain Greenhouse Mission Flatland is running out. That's not a distant concern, it's a present-day constraint driving agricultural planners around the world to think differently about where food can actually be grown. In Jiangsu province, China's answer to that problem was to go uphill. Engineers and farmers collaborated to build a high-standard vegetable greenhouse complex on a mountainside fully equipped with intelligent temperature control, automated irrigation, and real-time crop monitoring managed through cloud-based systems. The structural and logistical challenges of building on elevated terrain were considerable. The greenhouses were positioned carefully to maximize sun exposure, reinforced to handle mountain weather, and connected to remote management systems that let farmers monitor and respond to crop data from a smartphone anywhere. The result is year-round vegetable production, independent of outdoor conditions, in a location where conventional farming would have been dismissed as impractical. It's a proof of concept with serious implications if this model is replicable. The mountain terrain that covers vast portions of China and other nations stops being a limitation and starts being available farmland. Number 1. Chili harvesting machine. Closing the list with something that captures everything. This agricultural revolution is really about a machine built not for a flashy demo, but to solve a genuine problem in one of China's most important and labor-intensive crops. Chili farming is enormous in regions like Xinjiang and Sichuan. The demand is consistent and high. The harvest, however, is physically brutal workers bent over in summer heat, picking by hand, managing a few hundred pounds per person per day. The automatic chili harvesting machine changes that math completely. With wide rotating arms that move through the field covering multiple rows simultaneously, it pulls ripe chilies cleanly from the plant without damaging stems or fruit. The built-in sorting mechanism then separates chilies from leaves and debris as they're collected, reducing post-harvest processing time significantly. Output runs into several thousand pounds per hour. That's not an incremental improvement over manual labor. It's a different category of performance entirely. In a region where labor is becoming harder to find and production demands aren't shrinking, a machine that harvests faster, more cleanly, and without stopping is exactly what food security at scale requires. If this is what chili farming looks like now, the transformation of every other labor-intensive crop is only a matter of time. 14 inventions. One very clear direction. The farm of the future runs on code, cameras, and machines that don't sleep. From a 2.0-story vertical farm in Shanghai to a laser robot hunting weeds in an open field, China is building an agricultural system that looks nothing like what came before it. Whether that's exciting or unsettling probably depends on where you sit. Either way, it's happening. If you want to see more content covering the technology that's actually reshaping the world, subscribe and hit the bell. Drop a comment below telling me which invention surprised you the most. I'm genuinely curious. See you in the next one.